Hi, am I audible to you all?
Yes, sir.
Okay, so can you see the screen?
Yes,
Sir,
sir.
I can see the screen. Can see the screen.
So we have almost completed conic section. Okay, only few portion, just kind of quick revision. So have you tried solving problems from this exercise 11.4? Anyone? And did you guys? Is it okay with you to solve problems from? Let's. Have you tried or not? First, tell me that, so that I can, proceed. Huh? Did you try it?
Yes, sir.
Okay, solve question number 4.
Sir,
Find the
exercise 11.4.
11.4.
Okay. Sir.
So I have written it here on the screen. 11.4, question number 4. So the equation of parabola is given 16x square minus 9y square is equal to 576. Okay. Find the coordinate of foci, vertices, eccentricity, length of lattice rectum of the hyperbola. Yeah. So what's the standard equation of hyperbola? Anyone?
X square by square plus y square by b square is equal to 1.
Okay. So x square by a square minus y square by b square is equal to 1. Okay. Yeah. So find a, b. First, always find out a and b if possible. So write this equation. Write this equation in this form. So how you will do it? See, your given equation is 16x square minus 9y square is equal to 576. Now in the right hand side, you need 1. So what you do? You divide entire equation by 1. Okay, so what you'll get 16x square upon 576 minus 9 upon 576 y square is equal to 1, right? Now find out x square. This is how much? X square upon how much?
By 9, sir.
X square upon 36 you will get. No? Sorry,
9.
sorry.
Sir.
9, is it? Yeah, it's a 9 square, right?
Yes, sir. Yes.
9, no, not 9 square.
No, sir. 3 square 9.
9 upon 576 is how much? Sorry, 576 upon 9 is how much?
64, sir.
64. So, and the 756 upon 16? Sorry, 576 upon 16 is how much? 36, right?
Yes, sir. Yes.
Yes, sir.
That's what I was writing. No? Okay. So y square upon 64 is equal to 1. Is that okay? That means can we write x square upon 6 square minus y square upon 8 square is equal to 1. Now see here, a is smaller than b. We have written this equation. We have written the given equation of parabola in this form, right? Isn't it? This is the standard equation, no, of parabola. Sorry, hyperbola. Why I'm saying parabola? Yes.
Yes.
Now A is how much? A is how much? 6. B is how much? 8. That means B is greater than A. So eccentricity will be equal to what? Yes, sir. Tell me eccentricity. Anyone, please tell me eccentricity. How do you find eccentricity, yaar? Square
1
root
by
of 1 plus A by B whole square. Is it or not?
sir, yes, sir.
Are you sure? A by B or B by A? Is it correct?
Sir, B square, B by A, sir. B by A, sir. B by A,
Are
sir.
you sure B by A?
Sir,
You are
yes, sir.
saying E is equal to square root of 1 plus B by A whole square.
Sir.
Why? Which one is correct? A, first one or second one? Which one is correct? Sir, this one is correct, no? Second one.
Sir.
So E is equal to 1 plus B is how much? 8 upon 6 whole square. Square root. How much we are getting? 36 plus 64 is how much? 100. That means 10 upon 6, which is 5 upon 3. E is equal to 5 upon 3. Okay, this is not correct. All right. Okay, so how do you find length of lattice rectum? So vertices, what are the coordinates of vertices? Coordinates of foci will be what? What are the coordinates of foci? Plus or minus A, E, comma 0, is it? Yes or no? So focus will be plus or minus A. A is how much? 6 into E is 5 by 3. Okay, comma 0. How much you are getting? S is plus or minus 10 comma 0, right? Now vertices, this is foci vertices A. How do you find vertices? Plus or minus what? A comma 0, no? A plus minus A comma 0. That's the vertex. A is how much? 6 comma 0. So you got foci, you got vertex, you got eccentricity. What else? Length of lattice rectum. What is the length of lattice rectum for this parabola? 2b square upon A. That's what we have studied. So 2 times of B. B is how much? 8. B square is how much? 64 upon A is how much? 6. How much is this? How much will be that? 3. So 64 upon 3. That will be your unit. Is the length of lattice rectum. Okay. See, this is which parabola? This parabola is Sorry, not why why I keep saying parabola. I'm sorry. This is hyperbola. Okay. So what hyperbola is this? Huh? Anyone? How do you define this hyperbola? Anyone, please tell me how you will define this hyperbola. What axis is there? Which is this axis? Which axis is this one? Which axis is this one? Anyone, please tell
X-axis,
me.
Y-axis, sir.
Are not x-axis, y-axis. That's what I've been teaching in parabola, hyperbola. Whichever one is conjugate axis? This one is conjugate axis, right? And this one is your transverse axis.
Yes, sir.
What, yeah? Okay, where is the focus? So this is S, this is S dash. S is A, sorry, S is AE comma 0, S dash is minus AE comma 0. Vertex, this. So A dash. A dash is what? A minus A comma 0. A is what? A comma 0. Focus. Now, where is the latus rectum? What is latus rectum? It's a chord which passes through focus. That means it's a focal chord, and it is perpendicular on the transverse axis. Okay, that is called latus rectum. So this is your latus rectum. Let's bend it a little bit. Okay, so let's say this. This is your latus rectum. Let's say X, Y. XY is your latus rectum, and one more latus rectum is where? That passes through this focus. Kind of. Okay. So this is another latus rectum. Where is the directrix? Directrix is here. First directrix, second directrix. Understood? What is the equation of directrix? X is equal to, this is A upon E. X is equal to minus A upon E. And I got it? This is origin, which is, or you can say center of hyperbola C, which is 0, 0. Okay. Now this is which hyperbola? This hyperbola is x square upon a square minus y square upon b square is equal to 1. It doesn't matter A is greater or B is greater. Okay. Now we have another type of hyperbola, that is what type? What is that hyperbola called? Conjugate hyperbola. Is it there in your syllabus? Conjugate hyperbola. What is conjugate hyperbola? It is defined as minus x square upon a square plus y square upon b square is equal to 1. So this is conjugate of which one? This is conjugate hyperbola. Okay, this hyperbola. Conjugate of x square upon a square minus y square upon b square is equal to 1. So conjugate of this hyperbola. How you will draw this hyperbola? So this is called conjugate hyperbola. X, Y. Now see, X is negative, right? X is in the negative direction. So this hyperbola we are talking about here. Okay. So this is the hyperbola we are talking about. All right. This is this hyperbola. This one. Minus of x square upon a square plus y square upon b square is equal to 1. All right. This is called conjugate hyperbola. So where is its focus? Let's say this S 0 comma BE, and this will be S dash second focus, which is 0 comma negative BE. See, if you have understood one hyperbola, it's exactly opposite that another hyperbola. That's why it is called conjugate, right? So focus, same directrix, length of lattice rectum. All right, so directrix will be here. These two are the directrix. Now the equation, can anyone tell me the equation of directrix? Let's say this is first directrix. What is the equation of first directrix? What is the equation of second directrix? Can anyone tell me? Yes, tell me, please. Please try. What will be the equation of this directrix? See, this directrix is x is equal to a upon e. This is y, x is equal to minus a upon e. What will be the equation of this directrix? D1.
Y is equal to A upon E and Y is equal to minus A upon E, sir.
B upon e, sir.
B upon E.
Yes, y is equal to minus b upon e. Okay. Now, similarly, can anyone tell me what will be the length of lattice rectum? This is the length of lattice rectum. Okay. What will be the length of lattice rectum? Length of lattice rectum. See, x, y is the lattice rectum. X, let's say x dash, y dash, x, y. So length of x, y, how you will find out? Length of lattice rectum. It is kind of similar. 2a square upon b. See, there it was 2b square upon a, right? In this parabola. Sorry, hyperbola. Why I keep saying parabola? See, how much is the length of lattice rectum? 2b square upon a. For this one, 2a square upon b. Got it? Yeah. What will be the eccentricity? Square root of 1 plus a square upon b square. Got it? Eccentricity is always greater than 1. Then only it is hyperbola. Otherwise, see, that's why it has to be plus here. It cannot be minus. In case of ellipse, it is minus. Okay?
Okay, sir.
Okay, what else? What else? Vertices. What are the vertices? Let's say this is a dash and this is a. These are the vertices. So what will the a comma a dash, how you can write? Vertices. 0 comma plus or minus b, isn't it? This is 0 comma b. This is 0 comma minus b. All right. Okay. Solve a problem based on it. So the eccentricity of a conjugate hyperbola, and the equation of hyperbola is x square minus 3y square is equal to 1. All right. Now find the eccentricity. Find E. See, for hyperbola, if you are getting E lesser than 1, that means there is something wrong. Okay. Yes, sir. Anyone, please tell me. How much is E here? How do you find E? What hyperbola is this? What hyperbola is this? This is normal hyperbola, right? So what will be its conjugate? See, for this hyperbola, E is equal to square root of 1 plus what? B upon A whole square. But I asked you to find for its conjugate. So what will be its conjugate? Its conjugate will be minus x square plus 3y square is equal to 1. That will be the conjugate. Okay, for this hyperbola, that means you need to find out. So can you write this as minus x square upon 1 plus y square upon 1 by 3 is equal to 1? Huh? That means A is equal to 1, B is equal to square root of 1 upon 3, isn't it? So E will be equal for this hyperbola. This is for this hyperbola. For this hyperbola, E is equal to square root of 1 plus B upon A whole square. How much will be that? 1 plus B square is how much? 1 upon 3 and 1 square root. How much you are getting? So 3 plus 1, 4. Sorry, A upon B, no, sorry. A upon B it is. This will be A upon B whole square. So this you will get square root of 1 plus A square is 1, B square is 1 upon 3. That means 1 upon 3. That means square root of 1 plus 3, square root of 4, that is equal to 2. So eccentricity of this hyperbola will be equal to 2. Conjugate of this hyperbola is 2. See, the eccentricity of this hyperbola will be how much? What will be the eccentricity of this hyperbola? Anyone, please tell me. Write down this equation in standard form. So this will be x square upon 1 minus y square upon 1 upon 3 is equal to 1. So for this hyperbola, this is the eccentricity. Right? A is equal to 1, B is equal to 1 by 3. What will be the eccentricity here? Square root of 1 plus B is square root of 1 by 3. So B square upon A square. So B square is 1 upon 3. So this will be 2 upon root 3. Okay. So the eccentricity of this hyperbola is equal to 2 upon root 3, and the eccentricity of this hyperbola is 2. Understood? Got it?
Yes, sir.
Okay. Oof. Does anyone know about rectangular hyperbola or equilateral hyperbola? Huh? Anyone? See here, length of conjugate axis is equal to length of transverse axis. Length of transverse. Okay, that means A is equal to B. Got it? So these type of parabolas are called equilateral. Sorry, not hyperbolas, are called equilateral hyperbolas. Understood? Got it? So what will be its eccentricity? So that means the equation will become what? X square upon A square minus Y square upon B square is equal to 1. That's the standard equation. Now you substitute it here. What you will get? X square, sorry, A square, no? X square upon A square minus Y square upon A square is equal to 1. So x square minus Y square minus A square is equal to 0. Or you can also write is equal to A square. Okay. Understood? Yes, sir. So it's, if you find out its eccentricity, E is equal to what? Square root of 1 plus B by A whole square, right? Now B and A are equal, so this will be 1 plus 1, right? So E is always equal to square root of 2. eccentricity is always square root of 2 of these type of hyperbolas. Understood? So if you draw these hyperbolas on x and xy plane, if you draw this hyperbola, say this. Okay, so it will look like, let's draw the hyperbola. Okay. So these hyperbola, so this is y, x, everything will remain same, but its tangent, if you draw the tangent, let's draw it here. These are called asymptotes, tangent at infinity. Okay, asymptotes will make angle 45 degree. And actually it must pass through origin, because my hyperbola is not perfect, so I'm sorry. So if you draw the asymptotes, it must pass through origin. Okay. So this will make angle 45 degree with all the axes. Okay. So this is called equilateral hyperbola. Okay, these type of hyperbolas are called equilateral hyperbolas. And of course, the equation of these line is y is equal to x, and this one is y is equal to minus x. Okay, so these are the asymptotes. Let me write down. Just a minute, I'm getting a call. Asymptotes. What do you mean by asymptotes? Tangents at infinity. That means it will meet at infinity. Means, see, this line is tangent on this curve, and these two curve, this will be tangent at infinity. At infinity, it will meet somewhere. That's why it is called asymptotes. It will not move. Like you have drawn the graph of 10x, right? Isn't it? Yes or no? Like let's see this one. Okay. Okay, so what's the equation? X square minus y square is equal to some value, let's say 3. So these are called equilateral hyperbolas. Okay, got it? 3, or it depends upon what values you put. See, the bending of curve will depend upon the value of constant. So let's say you put 100. Okay, so if you'll put 100, so it will look like that. Got it? So this is your equilateral hyperbola. Understood? You see the curve here, this curve, and this equation. Can you see this equation? X square minus y square is equal to 100. That means 10 square. So here the value of a and b is 100. You can also plot, let's say, see all functions. I don't know if the functions are here. Divided by, let's say, 10. Here, let's say divided by 9. Okay, and this is should be equal to 1. See, this is the hyperbola. How it will look like. So this is the equation of hyperbola. It looks like how does it look like? It looks like a straight line if you zoom out, right? It looks like that. But it's a hyperbola which you can see only at this point. It depends upon the value of x and y. Sorry, the constants a and b. How the hyperbola will look like. Got it? Understood? Whew. Okay, so next one is one type of hyperbola is called, see, this equilateral hyperbola. There is a type of equilateral hyperbola when, okay, that is called rectangular hyperbola. Okay, this hyperbola is really important and it has been used a lot. Okay, so x into y is equal to some constant, let's say c square. So these type of hyperbola are called rectangular hyperbola. Okay, so the vertex or the vertices of this hyperbola is c comma c and minus c comma minus c. Okay, foci or foci, whatever you say, is square root of 2, because eccentricity is E is always equal to square root of 2, right? Because it's a type of equilateral hyperbola. Type of equilateral hyperbola. Okay. Square root of 2 times of c comma square root of 2 times of c and minus square root of 2c comma minus square root of 2c. All right. The directrix is equal to the equation of directrix is x plus y is equal to plus or minus square root of 2c, and length of lattice rectum is equal to 2 times of 2c. Okay, these are the properties of this rectangular hyperbola and how it looks like. Let's see that. So this is y, x. See, rectangular hyperbola, it will look like this. So this curve is very, you will see in your everyday life. Everywhere you'll have this type of curves. Okay, so this is your rectangular hyperbola. Now see, where is its vertex? So its vertex will be here, right? Because you will join these two lines. So that will be as your transverse axis. Transverse axis must pass through here. Okay, and this should be perpendicular. So let's say something like that. Okay. Now this point, so this point is c comma c. This point is minus c comma minus c, because it is in fourth quadrant, isn't it? So this is your rectangular hyperbola. This is your vertex. Let's say a dash. That's your vertex a. Focus s. S will be where? It will be somewhere around here. So let's say this is s dash, which is square root of 2 minus square root of 2c comma minus square root of 2c, and if you extend it here, so this s, which is square root of 2c comma square root of 2c. All right. Now what will be its lattice rectum? Lattice rectum will be here. That passes through focus. Okay. So that will be your lattice. If you extend, of course, it has to intersect the curve somewhere here. Okay, so that will be your lattice rectum. Okay, So this is, let us got it. So these are the types of hyperbola that you have to study. Maybe direct equations are not there, but indirectly you will reach to that equation. Let's see these type of hyperbola, how you can plot it. So we saw that this is, sorry, x into y, right? So if you plot x into y is equal to some value, where is it equal to, let's say 9. You see how it looks like. Now where is its focus? Vertex is here. So vertex will be 3 comma c square, right? So vertex is plus or minus, where is 3? See, it is 3 and 3. So this is the vertex. This will be the vertex. Can you see this, everyone? 3, 3. So let's point 3, comma 3. So that's the vertex. Got it? Now another point. Let's have another point, minus 3, comma minus 3. So that will be your another vertex. You see, these are the vertices. A focus, well, where the focus will lie? Root 2 times of 3. How much is root 2 times of 3? Okay, let's write it like this. 2 to 3. Root 2 times, so square root of 2 into 3, square root of 2 into 3. So this is one of the focus. You see this one? This is one of the focus. Got it? Understood or not? Are you getting it or not? So that is one of the focus. Another, you can again plot another focus here. So again, it will be root 2 so this is minus, right? Minus root 2 times. It's very hard to copy this. Not able to copy it here. Let's check. Oh, okay. So you got it, meaning you got it, right? Now you take any point. Let's say this point. All the points will satisfy this hyperbola. You take any point, it will follow the equation x into y is equal to 9. X into y is equal to 9. So see, the product of x into y can never be equal to 0. Why? Because neither x nor y is 0. Got it? Because at 0, if one is 0, another one is infinity. Can you see that? Understood this hyperbola? Sorry. Okay, so let's solve another problems from NCERT book. So these are the several types of parabola that you are going to study. Now solve same exercise 11.4, question number let's say 10. So the foci of the hyperbola is given. F is plus minus 5. It's S, I usually write S plus or minus 5 comma 0, and the length transverse axis, length of transverse axis, that means A is given 8. Okay, now find out the value, find out the equation of parabola, sorry, hyperbola. I'm really sorry guys, I keep saying parabola, but it's hyperbola. Find the equation of hyperbola. Find the equation of hyperbola. How you will find it? See, equation of hyperbola is what? X square upon a square minus y square upon b square is equal to 1. See, everything is there. You need to find b. How you will find b? Yeah, anybody's there online or you guys left already?
So yes, sir.
Tell me the values. Ashwin, Hari, Murli, Shrikriti. How you will find? Tell me at least that. Murli, how you will find B? Murli?
Sir, yes, sir. 1 second.
Yeah, how you will find B? Tell me the process. See, what are the coordinates of focus? Right? So from here, you will
E.
find the value of eccentricity. So A into E is given how much? 5?
Yes,
Is
sir.
it A into A into E is 5 and A value is how much? 8. Is it?
Yes, sir.
Just wait, let me check. Transverse axis of the, see, A, no, it's 2A is given. See, transverse axis, length of transverse axis is how much? See, I'm sorry. See, length of transverse axis is, that means this value they're talking about, from here to here. And we know from here to here it is A. So this is semi-transverse axis, right? And here to here it is A. So 2A value is given. Okay. So 2A is 8. That means A will be equal to how much? 4. Sorry. A will be equal to 4. So E will be equal to how much? 5 upon 4. Now you know the value of E. What is eccentricity? How you find eccentricity? Square root of 1 plus what?
B square minus A square.
B by A whole square or B square upon A square. Find the value. Now eccentricity you have already got. Find the value of B. Yeah, how much you got? Anyone, please tell me. B is how much? Right? So this will be 25 by 16 minus 1 is equal to B square upon A square. This will be how much? 9 upon 16. 9 upon 16 multiplied by A square. A square is how much? 16 is equal to B square. 16 cancelled. B will be equal to plus or minus 3. Okay. Or so equation of hyperbola will become what? That means B square you are getting 9, right? B square will be equal to 9. So equation of hyperbola will be x square upon 16 minus y square upon 9 is equal to 1. Okay. Understood, or anybody is having doubt? Check it out. Check out this one. Okay, done. Solve question number 15. So focus is given 0. What type of hyperbola is this? Passing through which point? 2, 3. Okay. So it is focus given and the hyperbola is passing through this point. What type of hyperbola is this? Ask Shrikruti. Murli, what type of hyperbola is this? What type of hyperbola? We just studied a bit. What type of hyperbola? Conjugate hyperbola. See, x is negative and y is positive, right?
Yes, sir.
Means x square, not x. X square is positive, negative, and y square is. So see, focus is getting why it is this type, because focus is on y axis, right? Focus is on y axis. That means it is a conjugate hyperbola. Conjugate hyperbola. Okay. So what is the coordinate of focus? The focus is S 0, plus or minus BE. So the product of B is given square root of 10. B is not given, E is not given, but BE is given, right? So BE is equal to square root of 10. All right. Now it is also given that it is, so what will be the equation of this hyperbola? Y square minus B square minus X square upon A square is equal to 1. So this point will satisfy this hyperbola, right? So if you plug this point P in the given hyperbola, conjugate hyperbola, what you can write? So X value is 2, Y value is 3. So 3 square upon B square minus 4, sorry, 2 square, that means 4, or let's write 2 square upon A square is equal to 1. Okay. And the product of A is given, that means, sorry, B square, E square is equal to how much? 10. Can you find A square? Yeah. Yes, sir. How you will solve it? Anyone, please. See, what is eccentricity? How do we calculate eccentricity? E is equal to square root of 1 plus,
B square by A square.
A by B whole square, yeah. This is conjugate hyperbola, no?
Oh, yes, sir.
Conjugate hyperbola this. So let's write down. So this will be E. Can we write E square is equal to 1 plus A square upon B square? Right? Now E square into B square is equal to B square plus A square. Can we write like this? Just check if it is correct or not. Huh? No. Yes or no? Not getting. This till this far it is fine, right? So you take LCM. LCM you will take what will happen? This will become B square plus A square upon B square. Now just multiply it this side. So what it will become? E square into B square will be equal to 1 B square plus A square. Yes. So E square into B square will be equal to 1 B square plus A square. Now you substitute it this value here. What you will get? If you'll substitute, so you'll get A square plus B square is equal to 10. See, you have two equations. You have, see, equation number 1, equation number 2. Two equations, two variables. Solve it, find the value of A square and B square. See this, what else you can write this? How else you can write this one? Oh,
Sir, A square is equal to 10 minus B square.
okay. So can you write 9 upon A square? Sorry, B square, no, it is. Nine upon B square minus 4 upon what? A square is how much? A square can we write 10 minus B square? Huh? Is equal to 1. Can we write like this? Now just take LCM and cross multiply. So solve this one. Solve this one and tell me the value of B. Tell me the value of B square. Yes, tell me the value of B square. So 9 upon what? How much? B square, right? 9 upon B square minus 4 upon 10 minus B square is equal to 1. So can you write 90 minus 9B square minus 4B square upon B square into 10 minus B square is equal to 1, right? So this will become 90 minus 9 and 4 is how much? 13B square will be equal to 10B square minus B square whole square. Okay, B square square. So we can write like this. This will become, now substitute B square is equal to X. So what can we write? Later we'll substitute. First we'll write it. So this will become a quadratic equation, right? So this will become B square whole square minus 23B square plus 90 is equal to 0. Now substitute B square is equal to X. So what it will become? X square minus 23X plus 90 is equal to 0. Find the value of X. Find X. Yes, sir. Find the value of X. Is the equation correct?
Yes, sir. I'm getting the same equation also.
Okay. Tell me. Find the value of X. Is 18 a factor of 19? Can we write this as x square minus 18x minus 5x. 18 into 5 is 90, right? Plus 90 is equal to 0. Is it correct? 18 into 5 is 90, no? Yeah, 18 into 5 is 90. So this is correct. So now take x square. So x minus 18. Can we write it as x minus 18 into x minus 5? Is that correct? Okay. I missed one step. So let me write that step as well. We can write this as, let's take x common. So x minus 18. Fine.
Sir, I'm getting 18 or 5. Sir.
Is that correct?
Yes, sir. 18, comma 5. Sir.
X minus 18 is equal to 0. So x we are getting 5 and 18, right? That means x is what? B square. Isn't it? B square. That means we are getting 5 and 18. That's what we are getting now. So what will be the value of a square? See, from here, what we have got? This equation, see. E square into b square is equal to b square plus a square. E square into b square is equal to a square plus b square. Can we find the value of, and now we have got, and this is equal to 10, right? So a square plus b square is equal to 10. We know this, isn't it? And b square we are getting 5. So a square, how much a square will be? Plus 5 is equal to 10. So a square will be 5, comma. Now another equation, a square plus 18 is equal to 10. Sorry, yeah, 10. So a square will be equal to minus 8, which is not possible. Okay, because a square value, if it is minus, so that means a is complex, which we are studying about only real accesses, right? We are talking about real access, not complex numbers. Okay, so this is not possible. All right, so a square is equal to 5, for which b square is also equal to 5. Got it? Understood or not? So the equation of hyperbola will become y square upon 5 minus x square upon 5 is equal to 1. What type of hyperbola is this? We have studied just now. What type of hyperbola is this? These type of hyperbolas are called equilateral hyperbolas. Right? We had studied equilateral hyperbola, see, where A is equal to B. Isn't it? That's what we have got. Isn't it? That means eccentricity will be equal to how much? Square root of 2. So if you find E, find out value of E. From here, you substitute, find out the value of E. So E square will be equal to what? 1 plus b a square upon b square. A square is how much? 5. B square is how much? 5. So E will be what? Square root of 2, right? Equilateral hyperbola. Understood? Yes or no? Tell me, did you understand this one or not?
Yes, sir.
Okay. So we'll end the class here. I think you have chemistry class. So, and please solve problems from your exercise. Otherwise, it's not possible to learn. It seems like you don't have doubts because you don't solve problems. See, the only way you are going to learn is by solving problems. Okay. If you are having problem solving a problem, then go with the solved examples. Okay. Go with the solved example. You can Google the answer as well. You'll get all the answers. But first try it. Okay. Try to solve miscellaneous exercise and ask me in tomorrow's class. Most probably tomorrow we'll have a very short class. So yeah, let's see that. Okay, so I'll keep the doubts for the doubt session tomorrow for this conic section. Okay, and next chapter, which one you want me to start? Because conic section is over. Which chapter you want me to do next?
Sir, 3D geometry or limits and derivatives.
3D geometry is there in your syllabus?
I think so.
I think so. I don't know if it is there or not.
Yes, sir.
Is it
Let's
there?
do limits and derivatives, sir.
Also,
Okay, sir. Limits and
we can start limits and derivation also, but sets, algebra, coordinate geometry, calculus, probability. Okay, let me see. You have chemistry class right now?
Yes, sir.
Okay. Okay. So limits and derivatives will do next. Okay.
Okay, sir.
Okay. Thank you. Bye.
Thank you, sir.
Please solve problems.
Yes, sir. Thank you, sir.
Thank you.